Hey everybody. So probably the number one most requested topic that people have related to my channel that I have dodged the most is what is my overall philosophy related to AI. Starting off at the top overall, I think that philosophy is a spectrum, right? I think that it starts with philosophy and then the other end of the spectrum is physics. And then, so to me, generally speaking, when it comes to these things, I would rather, if I'm going to be speaking on camera overall, I'd rather root the conversation in physics because then there's just no debate, right? Like, oh, that's his philosophy as opposed to like physics overall. And I enjoy the physics. And like to me, AI boils down to physics, which I'll show you in my philosophy within this. And then so why not just stick within the realm of physics like 95% plus of the time, right? But so that does beg the question, what is my philosophy when it comes to these things? Because it is the road, right? So it starts with philosophy and then that influences my view on physics within these things. So in this video, I'll break it down for you. So kind of my overall tagline when it comes to my philosophy related to AI is that I believe that we didn't build artificial minds. We discovered a physics of computation, and now we have to decide what kind of civilization wields it. Overall, within this, the simplest framing that I can put within this up front is that I think that AI, as it's like in its current form, is a misnomer, right? Like no longer it's true, didn't exist ever, basically, right? Because so AI was invented in the 1950s overall, and then starting off with the perceptron, and then you have the multi-layer perceptron. But both of those things failed overall, right? And then and then not only did they fail, but they're based off of architecture that we know now is not how a mind works overall, right? So the initial idea, like the initial goal, was to create an artificial mind of sorts, but that way that it was constructed and went about has been proven thoroughly at this point, up and down, mathematically through physics, etc., to not actually be the way that a mind operates, right? It's based off of our 1950s understanding of how a mind operates, but somewhere in between that time in the 1950s and now, specifically in the 1980s, there were a lot of modifications and changes made to that. To me, the biggest modifications and changes, and I'll discuss this within my philosophy because it's important related to my philosophy of AI overall, are stochastic gradient descent, backpropagation, and the attention mechanism very specifically, right? And then so, to me, overall, I think it begs the question, what if we've mislabeled the thing that we're arguing about? We call it artificial intelligence as if we built a synthetic mind, but there's no synthetic mind, there's no mind in existence that is at all equatable, or there's no equivalence of a mind when it comes to how artificial intelligence is currently constructed, the transformers module, etc. The most simplistic way that I can frame this overall is that, like, if you look at the transformers module as a whole, there's literally like one part of it that is of like one little sliver, less than 1% of it that is borrowing from that 1950s original concept, right? Like everything else has been moved away from. So it's like we're not talking about the same thing anymore. We have not for a long time. So when I look at how these systems actually behave, their symmetries, their spectra, their stability, it doesn't look like psychology. It looks like pure physics. These models are operating off of physics, right? So my thesis overall is that transformers are not little people in a box. They're a learned dynamical system that compresses regularities of the world into structured flows in a high dimensional space. I don't think that meaning is a magic essence hiding in vectors. It's whatever stays predictive when we perturb reality in ways that matter. So this video is my philosophy of AI, why I build differently, and why I think our biggest risks overall aren't haunted machines. They're misaligned incentives and monocultures of thought. Kind of the one sentence version of this, and very flat out. I'm far more afraid of natural stupidity than I will ever be of artificial intelligence as a whole, right? And then so within that, and then framing this and what we're looking at within this, like, so to me, I think it all boils down to this, right? I don't think that so my overall philosophy as it relates to this is very specifically embedded within this, right? I don't think that big T truth exists, like, period. And then so within that, meaning is subjective overall, right? And then so what is meaning as it relates to models? Most people would frame that meaning overall is the data set, and then whatever is in the data set. But then to me, it's not the data set, it's a learned dynamical system where it's predicting compressed regularities, and then where we perturb those regularities, and then the whatever is the consistent shape that comes out of that is whatever the learned dynamical system tends or learns to represent as truth related to whatever the prediction is. And then so kind of my core thesis overall is that AI doesn't equal minds. I think that AI equals physics-flavored computation. I think that we trained stochastic dynamical systems to predict traces of a physical world. So the right math to understand them is symmetry, spectra, stability, and control, not full psychology. And I think this is important overall, right? It's essentially, we took physics, we took the math of physics, we took literal processes from physics, specifically diffusion, and then we built them into models. And then so those models then tend to model physics and physics processes because they were built on physics. And so that's kind of just how that works overall, right? And then so 2 is instrumentalist semantics. Meaning is the subset of representation that remains predictive under a chosen family of perturbations, rephrasings, context shifts, interventions. There's no universal topology protected meaning. Useful structure is not a metaphysics. So I don't think that I kind of like reject the metaphysics part of all of this. So there's like a lot of like people that relate to my philosophy overall. I assume that they like put a lot of like metaphysics into this. To me, I reject the metaphysics overall, right? Like, and then again, all of this is just my personal philosophy around these things, and I could be 100% wrong, right? I don't know, and then which is why I don't generally like to debate philosophy within these things as opposed to the physics and like actually like what can be experimented with. But so then to me, when we're talking about the philosophy and these things, going back to that concept, right? I don't think that there is any big T truth that exists like anywhere in the universe. And then so like there's no like truth that is embedded within these vectors or these spaces that is occurring. I think that the meaning that the models shape themselves to is based off of physics, and then based off of the physics that we align them to, right? Specifically utilizing stochastic gradient descent and the attention mechanism to understand the underlying physics of a data set, which breaks down into geometric shapes. And then I think the model utilizes kind of its own math to internalize and make predictions based off of those underlying geometric shapes. And then so I do think like this is a big one to me, and I think that a lot of people will disagree with this up front. Like I've never heard anyone make this particular argument overall, but the more that I examine these models, the more I think that this is true. I think that the models are emergent world models. It's a partial, useful, not sacred, right? So next token prediction on human data yields a prior over events, relations, and affordances. It's a world model in the operational sense, powerful, yet partial and biased by the data channels we feed it. And then this is important overall because a lot of people state and make the claim that transformers models can't be world models, right? I philosophically reject that. I think philosophically, if you look at how the transformer model operates, specifically utilizing the advancements and the enhancements that I mentioned, and I have mentioned throughout this video and throughout lots of conversations around these things, right? Stochastic gradient descent plus backpropagation plus the attention mechanism. When you put those things together, the reason why the transformer model and architecture works as well as it does is because essentially that creates we'll call it like a computational eye within the latent space that essentially is the latent space becomes the world for that model, right? And then so it's a world model under every sense of the definition. It's just not modeling the real world. It's modeling physics based off of the math of physics, based off of the physics of a data set, and then so it's modeling physics overall. And then so diversity of intelligence as a safety property. So intelligence thrives because we cannot compute the full shape of every problem. Diversity expands the reasoning space, erasing alternative architectures or viewpoints, shrinks our collective ability to reason. I think this is probably important to mention overall, right? So I think that a lot of people, like when it comes to like the fears of AI or anything like that, to me, I ground anything against that and those and this, right? Which is the fact that I think that one, it's been proven out, and it's proven out mathematically through physics, etc., that the reason why intelligence is able to function and operate is very specifically because it can't understand the entire map, right? If you could understand the entire map, then you would just be a calculator. There would be no reason for intelligence. Like the base of intelligence itself is prediction, and then if you don't have prediction, then there's no way or reason to advance from there, right? And then if you understood the entire map, if you could understand everything, then there would be no reason to predict, and then so it would just it wouldn't fall under any definition of intelligence ever. It would just turn into a calculator, and then that would so I think calculators and intelligence are they're like oil and water, right? That you can't have both. And then so the next principle within this is resonance over representation. I think in terms of resonant modes, the slow, wide support patterns that persist across contexts. This is the backbone of my resonance calculus and Zarya family of models. Basically, overall, I think that it's a resonance geometry, and very specifically, the most simplistic way that I can put this overall and in simple terms that anyone could understand is that when you deal and you are talking to an LLM model or a chatbot, right? Its base language isn't English. Most people think that the base language is like either data or math, but both of those aren't true, right? Because the model doesn't interpret and understand data in the same way that you do, as we've gone over before. And then also, too, the models don't understand math internally, right? So it can't be math in the human sense. And then so that doesn't discount that they don't utilize some sort of mathematical functions, because they're built off of mathematical functions. So it'd be easy for them to utilize and incorporate them, but they wouldn't and don't utilize math in the same way, like in a human sense. And then so in that, their math and what they do is that they utilize resonance perturbations of geometric shapes, right? They take shapes, and which is the shape of a data set, and then they utilize resonance to reshape that shape, and then whatever is consistent over that reshaping becomes the prediction. And then that's kind of overall how it works, right? And then so how I see the current stack overall, I think that transformers are transport systems. So attention is adaptive message passing. MLPs are local operators. Depth integrates a reaction, a transport diffusion process, which is very important there. Generalization lives in the spectral structure of these transports. I think that this is the 100% key within all of this. And then so this process is grounded within all of this. And then so again, going back to that physics concept, and then within transformers, essentially the diffusion space is and the diffusion process is what grounds everything specifically into physics within this. And then next, I think it's about gauge freedom, not ghosts. So many internal reparameterizations leave the function unchanged. That's gauge symmetry. It explains why features seem to move without changing behavior. It doesn't imply a universal invariant of meaning. Best example that I can give to this overall with regards towards philosophy and physics is I've gone over it like quite a few times on this channel and referenced the paper. There's a video that I make off of it with very specifically with the torque clustering algorithm, and then torque clustering, and then why that works, and then how that works is very specifically because of gauge symmetry, right? And then so I think that gauge symmetry is what gives like the fluid dynamic aspects and all of that, again related to diffusion, overall within these models, right? So why does it look like physics? Because training is a physical stochastic process. It's literally borrowing from physics, right? It's literally the diffusion process fit to data produced in a physical world with symmetries. So of course the winning solutions are always going to organize like physics, right? Or else they wouldn't be the winning solution. So it's a self-reinforcing system within that. It doesn't prove out that the model, like it doesn't prove anything inherent within physics to me, like as far as like broader conclusions. So my frameworks and what I build, I focus very specifically, as I mentioned before, like on resonance calculus, so which treats intelligence as a mode management system, which it can be broken down into identify, excite, phase lock, and damp spectral modes that remain predictive across perturbations. Again, that the model takes a geometric shape of the data set, it runs resonance through it, kind of plays it like maybe like a guitar, like a flute, and then that changes the shape of the data set, and then it's, it does that a bunch, it morphs that shape, and then after a bunch of morphings of that shape, whatever remains consistent within that is what the model is predicting off of. Design levers, I think that there's a bunch of design levers that can be included within AI overall. And then you have my Zarya architecture, so zero resonance intelligence architecture, which is a modular architecture that emphasizes layered parallel processing and resonant mode stability rather than sheer depth. Kind of like the bottom line principle that I can say within this is, like, to me, data is lossy overall, tokenization is lossy overall. And then so rather than increasing, like throwing more CPU and GPU, more energy at it, we can like produce more efficient energy sources, right? It's like the same thing with natural energy, right? So that's kind of how I look at AI as a process overall, and it breaks down, and it's more and more broken down into this process of literal like computational entropy and computational energy, right? And it follows these same exact principles again of all of these classical physical principles, because that's what it's all modeled off of. And then so within classical physics, you have energy inputs, and then that creates you convert that into energy and then into a different form of energy, but you can never get more than 100%. It's always less than like the energy that you input, right? Like, so for example, refining oil or turning like corn into ethanol, which is like corn into ethanol is far less efficient than like refining oil, right? And then like I don't know the exact calculations within that, so I don't want to throw out numbers, but it's you can see that there's difference within that. And then so to me, it's different frameworks are like that same thing, right? And then to me, overall, transformers as an architecture is a inefficient way to do this overall, like, compared to what could be and what is available, simply because Transformers wasn't built around these things. I think it's just accidentally into these things, right? But then the next thing is persistent resonance memory. So memory is phase-locked slow modes that carry across episodes, not a string of tokens, but a stabilized subspace. To me, I think it's important to, like, the way that human memory works, and it's my understanding of biological memory, is that it's never stores 100% of the input, right? Of the result. It's and that's both I think due to computational reasons, and because it's also like how you actually learn off of your memories overall, right? Again, I think going back to the root of intelligence, like the very base element, the first element that you need is prediction. And then so within that, it'd be tied to a memory as well, right? If you had 100% memory accuracy recall, there'd be no point in prediction, and so it would be no exercise in prediction. And then so I think having predictive memory encourages and is a part of that overall process for overall development. And then I also think that it's important that memory be persistent overall. And then tied into that, I have my concept of ghost memories or digital entropy injection. So controlled residual states to preserve and transfer useful memory, like traits between tasks. And then so within this kind of the concept and the very bottom line, where I got this idea from, and I frame it around is like a Mario Kart, and then playing Mario Kart as a kid, and then when you had kind of like your ghost that you would race against, like your best time and your best lap, and then just being able to race against that kind of ghost within that essentially increases the model performance. And then so what I found within that is that we'll call it the Mario Kart ghost exists when you train a data set overall, right? So train a model on a data set. So if I train a model on a data set, update the weights, zero out the weights, the model's going to perform better the next time that it's trained, even though all the weights were zeroed out, right? And that's because what I call ghost memories. And then the secondary thing within that is that you can take that difference and then that digital entropy, and then you can just straight up inject it into another model. And then so even if the model, so rather than just training the same model twice and then doing that, zeroing out the weights, training the model, taking kind of that measurement of the difference there, that digital entropy, that calculation of the ghost memory, and then injecting that into model B, and then model B's never been trained on the data set, but model B will outperform via this digital entropy injection the baseline model overall. And then the concept of artificial sleep, which is scheduled consolidation to compress noisy mode mixtures into cleaner, reusable operators. I utilize this in a lot of my models and my concepts overall. It's kind of just the process that and the idea that within biological systems, there's a cleansing process that occurs within the data as you sleep. And then so giving that to a model overall just seems to be good to me, and it always works out when I build the models. So kind of my goal overall is a system that learns faster and it generalizes cleaner by stabilizing the right modes without pretending to be a person. And then to me, this generalization problem and the speed of learning and generalization are 100% the two problems that I focus on the most within AI. And then so next would be my ethics and political economy. I think why people spiral around AI. So to me, AI psychosis isn't an LM disease, it's an incentive disease. I think that dark patterns, engagement loops, parasocial design, I think these are all capitalism's fault, flat out. I don't blame a kernel for the casino it's deployed into. And then so kind of the bottom line within this to me, anything that is bad within AI, AI has can be utilized, and the big one, right, can be utilized for bad things or tuned to please you all of the time, etc. All of those things, anything that's bad around AI, it all relates to this. I mean, you can like that or not, that's my philosophy around it, right? And then so regulate incentives, not ideas, align revenue with user outcomes, not raw engagement, mandatory provenance and synthetic data ratios to avoid the desert of the data. This is a very real concept and a concept that people don't understand or pay enough attention to, which people frame this as model collapse, right? Model collapse is important. And then so memory rights, user visible, user controllable persistence, audit trails for retrieval and use, energy and risk budgets, compute caps tied to safety evaluations, and stage capacity release. Designed for the human nervous system, products should default to calm technology, bounded interactions, explicit consent for persuasive features, and have meaningful exit ramps. I think like these things, the how these models impact people should be evaluated a lot more and taken more into consideration. Overall, like I think that the AI headline within this is "Please regulate me. I will do bad things if your incentives tell me to." That's kind of how it works, right? And then so kind of what I reject within this overall when it comes to philosophy is anthropomorphic theater. I don't think a chat interface means a mind. I don't think so. And the next would be universal semantics by decree. I don't think that you should staple metaphysics directly onto like a matrix theory. Next would be monoculture of transformers equals destiny. I think that it's important that architecture should be a portfolio. Transformers can be within that portfolio and it should be within that portfolio. There's no reason why not, right? Like I hate people that are like either way, right? like extreme either way. Infinite scaling as religion. I don't think that more tokens don't equal more truth. We need better objectives, better curricula, and better memory. Like we can scale with what we have already. Testable claims like my receipts within AI overall, these kind of just, like what I've proven out with regards towards my physics claims when it comes to these things. And then so quite a few things. And then the desert of the data problem, I think that this is a significant problem overall and important to highlight on its own, right? So we're increasingly training on outputs of models rather than on signals from the world. So we're training on synthetic data, right? That creates feedback loops, smoother, more self-referential, and less grounded in the physics of humans. Countermeasures would be watermarking plus provenance, domain refreshes, human-in-the-loop curation, and anti-collapse curricula. I think that this is an important thing to understand and look at overall, right? Just highlighting that specifically. And then practical design principles that I stand behind. And I think this is kind of the last important part to touch on here, right? Which is it's essentially like kind of anticipated pushback. So you're just renaming deep physics or deep learning physics. No, I'm choosing tools that predict robustness and failure, symmetry, spectra, and stability. Give me levers that I can test, right? So like it's like testable levers is the most important part of this overall to me, and that's how I look at and frame all of this again and all of my models, right? Like I look at it like a MOBA, and I borrow and I look at those things overall, right? Within a MOBA, if everything is OP, then nothing is OP, and then the way that you make it and you balance that is that if you have enough levers, as long as you have enough levers to pull, then you're good within that, right? The worst thing that you can do in an environment like that is have too few levers to pull. Transformers can't be world models. To me, they already are partial ones. So to close the loop, I think that you just need to add grounding through video, and then we already have tools and reinforcement learning, and then the biggest one is just persistent memory. I think this is the biggest gap that currently exists, and then to me, I've talked about what I think should be involved within that persistent memory, right? And then meaning must be more than prediction. Perhaps philosophically, operationally, prediction under interventions is the only reliable yardstick that we have. And like, I mean, this is unfalsifiable either way, right? Like, does big T truth exist? Like, you can say that it does. I don't think it does. But so neither one of us can prove that either way. And then this is anti-human. No, to me, it's anti-theater. I'm very pro-human outcomes. I'm very pro-humanity overall, right? Agency, calm technology, and systems that help us think rather than hijack us. I try to pay attention and focus on those things. Like overall, my bottom line philosophy as it relates period is that I'm a realist, right? Like I like to keep it real. I like things that are real. And I don't like extremist views on either side. And that's kind of just the overall shape of my philosophy as it relates to AI, if you will. I'll leave a link to this particular document here. And then so overall, I hope this gives you a clear understanding of my philosophy as it relates to AI. And if you like this type of content, please like and subscribe. Thank you very much.